Hi everyone, welcome back to the channel. Today I'll be covering indices from the IGCSE Mathematics chapter, numbers, and we'll start off with covering what the rules are first, and then we'll go over some questions. So some of the very basic rules are a to the power m into a to the power n. When you see questions like this, what you should be doing is a to the power m plus n. So this only applies when the base are the same. In this case, both of these have a base of a, and therefore we can apply this rule and we would have to sum the powers. Next rule, which is similar, is for division. A to the power m divided by a to the power n. In this case, we have to subtract the powers. So it would be m minus n. And again, it would be only when the base are the same. For the third rule, we have a to the power m whole to the power n. This basically means that there is a variable that is raised to a power, and that entire thing is raised to another power. When this happens, you have to multiply the powers. So in this case, you would get a to the power mn, or m into n. Now, there are some cases where rule number 1 and rule number 2 can be a bit confusing because it may seem that the bases are not the same. So let's say we're given the example 3 square into 2 cube. Okay, and a lot of mistakes candidates make is that they assume you can multiply this, the bases, and then add the powers. So what they would do is 3 into 2, which gives you 6, and then 2 plus 3. So you end up getting 6 to the power 5. But that is in fact incorrect. It is not right to do this. But if you were, for example, given the question 9a squared into 9a cubed b to the power 5. So in this case, the square is applying to a, 9 is as it is, and in this case on the right side, the cube is being applied to a, and then the power 5 is being applied to b. So now, would you apply rules 1 and 2 to this? Do you think it is applicable? Well, in fact, it actually is, because one of the variables, or actually two of the variables here, are common. In this case, a and 9 are the same, and that's why you can actually apply this rule, because a variable of the base is the same. So if I had to apply this rule, I would first multiply the constants. So 9 into 9 is 81, and then I would apply the rule for variable a. So a squared, it will be plus 3. So a to the power 2 plus 3, because I'm multiplying this and this together. You always multiply the common ones, right? And then for b, we don't have anything on the left hand side, so we'll just have b to the power 5 over here. So this would be 81 into a to the power 5 b to the power 5. So the difference was that in this example over here, there was nothing common. But in this example here, we had some variables that were common, and that's why we can apply the first two rules. Now, the reason why I mentioned the third rule before moving on to these examples is because, let's say we were given the question 9 to the power 4 into 3 cubed. So you should automatically recognize that 3 squared is equal to 9. So I can substitute this over here instead of 9, so that my base would end up as 3. So I'd have 3 squared, and that to the power 4. Because instead of 9, I'm writing 3 squared. So I'll have to write the brackets, and then I'll have to raise the power 4 to it. And then I'd multiply it by 3 cubed. Now before I add the powers, I would first have to simplify this on the left hand side. So I'd have to apply the third rule over here. So it would be 3 raised to the power 2 into 4, and then that whole thing into 3 cubed. So essentially it would be 3 to the power 8 into 3 cubed. Now I can simply add the powers because now the base is the same. So 3 to the power 8 plus 3, that would give me 3 to the power 11. So whenever you're given questions with multiplication or division of bases with powers, you would have to see if you can make the base the same, and if not, see if there's any variable that is common in the base. Now moving on to some more basic rules. You should know that anything to the power 1 is equal to itself. So over here I have a to the power 1, that will equal to a. And the next rule, which is also quite simple, if anything is raised to 0, it will equal to 1. So a to the power 0 over here is equal to 1. Moving on to some more complicated examples or rules. So let's say we're given a fraction, a by b, and the whole thing is raised to a power m. You can apply this power to both the numerator and the denominator, because as you know, fractions can also indicate division taking place. So this would be a to the power m upon b to the power m. Same thing can happen when you have multiplication. So if you have a into b, the whole raised to the power m, then it would be a to the power m, b to the power m. So moving on to our next rule, let's say we're given a to the power negative m. In this case, that can be written as 1 upon a to the power m. Essentially, when you're given a negative power, you can move the entire number to a denominator and put 1 at the top, and you would remove the negative sign. So it would become a positive power. So a to the power negative m will become 1 upon a to the power m. Now here's an elaborated explanation of why number 8 is possible. Let's say we know this rule number 5, that a to the power 0 is equal to 1. So instead of having 1 written up here, let's say we had a to the power 0 divided by a to the power m, or upon a to the power m. So we know that fractions can also indicate division, and that basically means this is a to the power 0 divided by a to the power m. And because the base are the same, if I apply the division indices rule, which I've mentioned above, essentially what you're supposed to do is a to the power 0 minus m, and that will give you a to the power minus m. We know that over here a to the power 0 is equal to 1, so basically I wrote 1 upon a to the power m, and that's why a to the power minus m is equal to 1 upon a to the power m. So if, for example, we were given 9 to the power minus 2, that's basically 1 upon 9 square, or 1 upon 81. So let's say we were given a combination of rule 6 and rule 8. Let's say we were given a by b whole to the power negative m. So this isn't an exact rule, but it's a combination which I'll be using for explanation and for understanding. So what you should know is that if you're given a fraction or division and the whole thing is raised to the power or a negative power, you can reciprocate the fraction to give you a positive power. So this can be written as b by a whole to the power positive m. Now the reason why is, let's break this down a bit. So applying rule number 6 over here, I would basically be getting a to the power minus m upon b to the power minus m. So that's essentially a to the power minus m divided by b to the power minus m. Now if I applied rule number 8 to both of this, that's 1 upon a to the power m divided by 1 upon b to the power m. Now fraction division, if you don't know how that is done, I have a video explaining it and you should check that out. So you would have to keep the first fraction the same. So it would be 1 upon a to the power m. The division would change to multiplication and you would reciprocate the second fraction. So it would be b to the power m upon 1. Essentially, it would be b to the power m upon a to the power m, which can also be written as b by a whole to the power m, which is what I've stated here in rule number 9. So any fraction raised to the whole fraction raised to the power or a negative power, you can reciprocate that to make the power positive. Now moving on to the next rule. Let's say we were given a base raised to a fraction. So in this case, it's always going to be a root with the base raised to whatever the numerator was, and the root would be whatever the denominator was. So let's say we were given 4 raised to the power half. So that would be root with 4 raised to, what is the numerator over here? 1. And the root would be 2 because the denominator here is 2. Now another example, if we were given 24 to the power 3 by 8, this would mean 24 would be inside the root. 24 would be cubed because the numerator is 3 and the root would be 8. I would basically be getting a to the power minus m upon b to the power minus m. So that's essentially a to the power minus m divided by b to the power minus m. Now if I applied rule number 8 to both of this, that's 1 upon a to the power m divided by 1 upon b to the power m. Now fraction division, if you don't know how that is done, I have a video explaining it and you should check that out. So you would have to keep the first fraction the same. So it would be 1 upon a to the power m. The division would change to multiplication and you would reciprocate the second fraction. So it would be b to the power m upon 1. Essentially, it would be b to the power m upon a to the power m, which can also be written as b by a whole to the power m, which is what I've stated here in rule number 9. So any fraction raised to the whole fraction raised to the power or a negative power, you can reciprocate that to make the power positive. Now moving on to the next rule. Let's say we were given a base raised to a fraction. So in this case, it's always going to be a root with the base raised to whatever the numerator was, and the root would be whatever the denominator was. So let's say we were given 4 raised to the power half. So that would be root with 4 raised to, what is the numerator over here? 1. And the root would be 2 because the denominator here is 2. Now another example, if we were given 24 to the power 3 by 8, this would mean 24 would be inside the root. 24 would be cubed because the numerator is 3 and the root would be 8. Now let's move on to solving a few questions. So the first question we'll be doing, it's from summer 15. It's question paper 42. It's question 9C. So over here, we're given 16 by 9x to the power 4, and the whole thing raised to negative 3 by 2. So over here, 4 is the power of x only. It does not apply to 9. And this entire fraction is raised to the power negative 3 by 2. So I'll go ahead and make this a bit more elaborated than it should be. The first thing you can actually do is reciprocate the fraction to get a positive power. But what I'll do instead is apply the fraction rule when it's raised to a power. What I mean is, I'll make it 16 to the power negative 3 by 2 upon 9x4 whole to the power negative 3 by 2. So essentially I use the a by b whole raised to m is equal to a to the power m upon b to the power m rule over here. So this means 16 to the power negative 3 by 2 divided by 9x4 to the power negative 3 by 2. Now if I wrote this to apply the rule of anything raised to the power or negative power, this would be 1 upon 16 to the power 3 by 2 divided by 1 upon 9x to the power 4 whole raised to negative 3 by 2. So this here I'm applying that a to the power minus m is equal to 1 by a to the power m. Now because it's fractions that are dividing, I would apply the rules regarding that. So the first one will stay the same, 16 to the power 3 by 2, into reciprocate the second fraction. Oh, sorry, this here is supposed to be positive because I've applied the rule, this rule over here. Anyway, so I'd reciprocate the fraction to give me 9x to the power 4 whole raised to 3 by 2 divided by 1. And therefore that's 9x to the power 4, 3 by 2 into 16 raised to 3 by 2. So this entire part over here is fraction division. Now I would have to apply this power into everything inside this bracket. So this would be 9 to the power 3 by 2 into x to the power 4 whole raised to the power 3 by 2 upon 16 to the power 3 by 2. The reason why I'm applying the power to 9 as well is because I'm making use of the formula or the indices rule that ab whole raised to m is equal to a raised to m into b raised to m. This dot over here represents multiplication. So that's why it's 9 to the power 3 by 2 into x raised to 4 whole to the power 3 by 2. So 9 to the power 3 by 2, and this x raised to 4 whole to the power 3 by 2, these two numbers can be multiplied because it will be making use of the rule a to the power m raised to n is equal to a to the power m into n. So 4 into 3 by 2 is 6. So this would be x to the power 6 upon 16 to the power 3 by 2. Now you can simplify 9 to the power 3 by 2 in 16 to the power 3 by 2. So this question actually asks for simplification, so you can actually just type it into your calculator and raise it to the power 3 by 2, and you would get 9 to the power 3 by 2 is 27 into x to the power 6 upon 16 to the power 3 by 2 is 64. So this is your final answer. Now the reason why I decide to go along the more complicated way of doing this is so that I can show you where exactly I've applied which rules. And this method also contains fraction division. You can also just start off with reciprocating the fraction to begin with to make the power positive, and then apply the powers to them, and then you can go forward with expanding and simplifying. Now for our next question, this is from Winter 18, question paper 42, question 2C. So there are two parts to this question. The first part is very simple. It's 5a cubed c squared into 2a squared c7. So this is multiplication, and we have bases raised to powers. And in this case, we can see that the constants 5 and 2 are not the same, but we do have the base a and c, which is the same. Therefore, we can apply the first rule which we've discussed. So essentially what we'd have to do is first multiply 5 and 2, and then it would be a cubed into a square, and then c squared into c to the power 7. I basically grouped up the like terms together, and also because these are brackets right next to each other, they indicate multiplication taking place. So 5 into 2 is 10, and because it's a cubed into a squared, that would be a to the power 3 plus 2, and then it's c squared into c to the power 7, so it'd be c to the power 2 plus 7. So that would be 10 into a to the power 5 into c to the power 9. So the answer is 10 a to the power 5, c to the power 9. You don't actually have to show all of these steps. You can just go ahead and write the final answer as it is. Now moving on to part 2, which is a bit more complicated. We're given 16 a to the power 8 upon c to the power 12 and the whole raised to 3 by 4. So the first thing I'd like to do is apply the rule of a by b whole to the power m is equal to a to the power m upon b to the power m. So that would be 16 a to the power 8 raised to the whole raised to 3 by 4 upon c to the power 12 whole raised to 3 by 4. Now for the top part, or the numerator, I would be applying the rule that ab to the power m is equal to a to the power m and b to the power m into b to the power m. So in this case, 16 will be like our a, and a over here will be like our b. So this would be 16 to the power 3 by 4 into a to the power 8 whole to the power 3 by 4. And for the denominator, I'd be applying the rule that a to the power m raised to n, whole raised to n, is a to the power m into n. So it would be c to the power 12 into 3 by 4. I'd be applying the exact same rule over here as well. So that's 16 to the power 3 by 4 into a to the power 8 into 3 by 4. So 8 into 3 by 4 is 6 upon c to the power 12 into 3 by 4 is 9. So it's that, and 16 to the power 3 by 4 can be simplified to 8 when you type on your calculator. So it'd be 8 a to the power 6 upon c to the power 9. Okay, so now we'll move on to the next question. So in this question, we're given that 2 to the power r is equal to 1 by 16. And now we need to find what r is. So you should immediately recognize that 16 can be written as 4 square. So that'll be 1 by 4 square. And you should also know that 2 square is equal to 4. So this is why I've advised previously to know your square numbers and your cube numbers as well. So that's 1 by 2 square whole raised to 2, because instead of writing 4, I'm writing 2 square. So it'd be 2 square raised to the power 2, and that is basically 2 to the power 4. Why is it 2 to the power 4? Because I'm applying the rule that a to the power m whole raised to the power n is equal to a to the power m into n. So that's 2 raised to 2 into 2, and 2 into 2 is 4. So now to simplify it a bit more, I've basically written that 2 raised to r is equal to 1 upon 2 by 4. And I'd be applying the rule that a to the power negative m is equal to 1 upon a to the power m. So I can say that 1 upon 2 to the power 4 can be written as 2 to the power negative 4. Therefore, r should equal to negative 4. So moving on to the next question, we're given that 3 to the power t is equal to 5 root 3. So this is applying the rule that a to the power x by y is equal to y root a to the power x. So in this case, the power of 3 is 1 and the root over here is 5. So essentially this would be 3 raised to 1 by 5. So the base is the same, 3, 3. So t is equal to 1 by 5. If the base was not the same, we would have to try to make it the same and then see what the power will be. And t would be equal to that power. Now for the next question, we're told that 1 by 3 is raised to the power negative 2. The whole fraction is raised to the power negative 2, and we would have to simplify it. So two ways you can approach this. You can do a by b whole to the power m is equal to a to the power m upon b to the power m, and then you go on with fraction division. You apply those rules, but the simpler or quicker way to do it is to reciprocate the fraction and make the power positive. So you could do 3 by 1, and the whole thing would be positive power, raised to a positive power. So it will be just number 2, not negative 2. So 3 by 1 is essentially just 3. So this is basically 3 square. And 3 square, as you should know, is 9. Now for the next question, we're given that 16 x to the power 16 is raised to 3 by 4. So you would have to apply the formula that ab raised to m is equal to a to the power m into b to the power m. Also, as I solve these questions, I hope you take the time out to try and solve them by yourself and check the answer later. And obviously, I have explanations provided, so I hope they help. Anyway, so this would basically be 16 to the power 3 by 4 into x to the power 16 whole raised to 3 by 4. Now I would have to multiply these powers because I'll be using the rule that a to the power m whole to the power n is equal to a to the power m into n. So 16 raised to 3 by 4 is 8. So that can be simplified to 8, and then x raised to, what was that number? 16 into 3 by 4. We know that's 8. So this is the answer for that. Oh wait, my bad. Over here I did 16 raised to 3 by 4 to give me 8. Over here I'm doing 16 into 3 by 4. And 16 into 3 by 4 is actually 12, not 8. So please avoid such silly mistakes. Now we have our next example question that I suggest working out on your own. It's 2p raised to the power 3 by 2 is equal to 54, and we have to find p. So first you should solve it with basic algebra. Over here on the left hand side, 2 is being multiplied by p. So when you move it to the right hand side, it would be division. So essentially it would be p to the power 3 by 2 is equal to 54 divided by 2. So p to the power 3 by 2 is equal to 27. So essentially over here now we've come to the step that p raised to 3 by 2 is equal to 27. Now p raised to 3 by 2 basically means that p cubed and the root of that, because I'm applying the rule here that a raised to x by y is equal to a to the power x y root. So in this case, 3 is the power or the numerator and 2 is the denominator, so that would be the root. So square root of p cubed is equal to 27. That means if I take my square root to the right hand side, or if I square both sides, I'd be getting p cubed is equal to 27 square. So p would then equal to cube root of 27 square. So when you type that on the calculator, that's 9. So p over here is equal to 9. Now moving on to our next question, which is our last one. Let's say we're given half into x to the power 2 by 3. And this whole thing is raised to 3. So the first thing I do is apply the rule that ab whole raised to m is equal to a to the power m into b to the power m. So that would basically be this half raised to 3 into x to the power 2 by 3 raised to 3. So half cube or 0.5 cube would basically mean 1 cube upon 2 cube into x to the power 2 by 3 into 3. The reason why I'm doing 2 by 3 into 3 is because I'm applying the rule that a to the power m whole raised to the power n is equal to a to the power m into n. So 3 into 2 by 3, the 3's would basically cancel and you'd get x squared. 1 cube is still 1. This would be x squared. And 2 cube is 8. So this is the final answer you'll be getting, which can also be written as x squared by 8. So that's it for this video. I hope it makes sense. If you have any doubts or questions regarding this lesson, feel free to leave them in the comment section below. If this helped, consider liking and subscribing. If you have any more doubts, you can check out our other lessons. And that is all. Thank you.